Okay, we've got. All right, we got heat. We got. That's hilarious.
Would minor updates, because I forgot to, like, you probably wouldn't want to update while you're like actively working on projects. Would minor updates like that flag
No, minors are not a
projects?
problem.
Okay.
Majors are. If it's like 5.3 to or 5.4 to 5.5, that's considered a major revision.
Okay.
So it's usually pretty scary. If we ever get a major revision, I would advise people do not update right away because it might break your project. It's rare, but it has happened. It's happened enough for me to be like, let's let's not. Also, I need time to kind of research what the changes are supposed to be and whatnot. Okay, so since I'm gonna be using this scene to kind of work through some of the lighting stuff and some of the stuff that I didn't get a chance to talk about, and I received a couple of questions related to one, custom skyboxes, which is really important to games development in general, and two, I believe a couple of people also had questions about creating a night scene or a night-based scene, etc. I'm going to demonstrate both just so people get an idea of kind of like the range of capacity that you have to work with. Now, it's not as simple as you think. There is no nighttime mode that you can just turn on. It's really just a lighting scheme. So let me go ahead and hit the lights here. Make sure I'm looking at the right thing.
I know.
What I want. Yeah. I might do a vertex paint just to show people kind of some other stuff here. Where is the stuff that I want though? That's what I want. At least for my notes purposes. Okay. All right. So, assets were open. I do not care about those assets. So, when it comes to lighting environments, now the reason why we can see this lighting again is really because we have the exponential height fog brought in here. Now I'm going to go ahead and delete the exponential height fog. And then I'm going to bring a new one in to show you kind of the difference between the fog that's in this file that is pre-set up for you and the fog that is generally what you get when you are bringing in an OEM original fog from the engine itself. And I'll explain kind of how it works. So I'm going to go ahead and grab the exponential height fog here. And as you can see, it is dragged in, but we don't see anything. Now the reason for that is because the original fog in Unreal is built with Lumen's idea of what the sky color is supposed to be in mind. So what you're seeing right now, what I'm highlighting right now is something called the fog interscattering color. Remember, it is not a fog light in principle, but it operates using light principles in general. So this oftentimes confuses students where it's like it's not a light, but it has light properties, so on and so forth. If we go ahead and crank that up, you can see that the behavior of the fog does return to kind of like like the behavior that we had at the beginning. What this is doing is this is the color of the light that is being fundamentally scattered from the sky sphere or the sky box or whatever you want to use. It works in conjunction with any of the assets in the environment. The exponential height fog is the gateway to volumetrics. Let me go ahead and show that while I still can. I'm just going to go ahead and back up a couple to bring the old one back. So we've got this light one kind of set up. And I'm going to go ahead and just kind of demonstrate the idea of volumetrics. Salud. Salud. Inside the exponential height fog, we actually have this element called volumetric fog. Volumetrics deals with the incandescent and otherwise dispersory dust that is in the environment, but is also visible because light particles, moisture, etc. are visible at any given time, but our eyes generally can't pick them up. What you are seeing when you turn on a flashlight during like a misty day here in San Diego, when you see the lightsaber effect, that's essentially what's called volumetrics. We used to call that volumetric fog, but volumetrics are expensive in principle. Now, depending on your overall horsepower of your machine, you might get slowed down or not. If you want, I'm sure people have heard the term God rays, right? If you want God rays, My advice is to build texture cards that look like God rays. Basically, create a God ray, make it transparent, and then kind of put them wherever you need. That's going to be how games generally, especially do budget style God rays. But if you're doing something on like a powerful machine, like a PlayStation, or I mean, is an Xbox considered a powerful machine? If you're doing it for PC or something that's equally powerful, if you have a 2060 at least, you open up the path to volumetrics. Volumetrics allows you to do stuff like this. So if I initiate volumetric fog here, you'll notice that the volume of the fog does change a little bit. Did everybody see that we had kind of like a different effect? What it means is that the volumetric calculation is trying its best to figure out what it's doing with the lighting. Let me go ahead and bring in a light, for example, here. Let me grab a spotlight here because that's going to be, not spotlight. I'm going to grab a spotlight here. I'm just going to bring that in. Now, Lumen is on right now. Oh my gosh, I remember I put that super cursed ground there. No worries. And what I'm going to do is I'm going to add a significant amount of power here. I'm just going to increase this to, let's go ahead and change this to lumens, which will give me some lumen power. I'm going to change this to about 500 lumens. And then I'm going to modify my attenuation radius just so I can get good fall off. And then I'm going to have an inner and outer cone. Okay. When you are working with any kind of lighting with exponential height fog turned on to demonstrate volumetrics, what you have access to is a volumetric scattering intensity amount in every light. I'm just going to crank this up to say maybe 50, and I'm going to hit G so that people see it. Now this has to do with a kind of a game engine doing game engine things. You see what I mean? You normally don't want that. This is cranked up beyond the scope of what it's supposed to be. But this is traditional volumetrics. This is a volumetric in a game. It's creating and casting volumetric light. That volumetric light is influencing the environment. And volumetric lighting does work in both light mass and lumen. Lumen is going to have an easier time calculating the additional light from volumetrics. But volumetrics essentially is the, you know, how else do you get like the drop or the drop light from like maybe a street light, so on and so forth. I've gotten a very extreme example here. You'd probably want to crank this down pretty significantly. Probably like that. But you get the idea. You see the volumetrics still. In fact, you can even see better on this TV than I can on my Cintiq here. But you get the idea. And it looks a lot more comfortable and it doesn't swim. When something is moving on screen and it's behaving in a weird way, we call it jittering or swimming. It's basically like it's paddling. It's doing something to where it's visible. If you can see it, the players can see it. That's just kind of the rule. So volumetrics opens up the ways to things like rays of light, to things like, let me go ahead and make a point light here. In fact, I can just do L and left click to create a point light. Let me move this over, and I'm going to go ahead and increase the volumetrics just so we can see it. We can increase the luminosity of that to create like an area that has certain volumetrics. This is what creates kind of like area fog in a game. This is cheaper than loading the entire area with a thick fog, if that makes sense. Because the volumetrics are calculated based on your attenuation radius. So do you see how the fog is calculated based on the attenuation radius of that light? This makes it perform better than using a global fog or basically just turning up the exponential height fog to a point where it's going to be able to be seen. That's kind of a big mistake that a lot of students make initially when they're trying to create volumetrics. They think all they have to do is crank the fog up and it'll be fine, but the higher you crank the fog, the more it costs. This is a little bit better, although there's different ways of kind of approaching this particular problem. This is still not as cheap as it can be, but it's considered pretty standard for creating like, oh, I'm walking into an area with a slight amount of fog. Well, you can create a shaped light that is going to have that behavior. For example, if I grab a quad light, a rect light, and then I go ahead, I like to use lumen lights when I need volumetrics. Lumens are a higher, remember we already talked about that last week. Candles is candle power. Lumens is a higher multiple of lighting in general, and I tend to prefer it when I'm doing any kind of volumetrics. We can go ahead and crank that up. Again, I'm just demonstrating here. And because of the way that barn dooring works, we can really kind of extend the way that the behavior of this works. So we can go ahead and change the width and the height of this. And it gives us kind of like, does everybody see kind of how that behavior follows along with the lighting? Crank it up some more. Here, we'll crank it up to where we can actually physically see it. So that's a pretty good so that's kind of how you create like those effects where it's like, oh, walk into the magic door. This area is visible, right? Volumetrics are just kind of the gateway to creating more interesting lighting within the lighting scenario of the environment. So remember, you are limited to using a handful of lights, but volumetrics in principle is how you create more interesting areas of lighting in general. But this is not the only way to create these types of rays and lights. When it comes to creating lighting in general, let me go ahead and demonstrate that. In fact, volumetrics are really expensive to have on. I'm going to go ahead and find the exponential height fog. My advice is turn that stuff on. It looks amazing. Even if your scene is encased or underground, volumetrics really does sell the effect, right? It just adds a little bit of something to the air that gives it depth, right? Let me go ahead and disable the volumetrics on my exponential height fog here. That's going to just give us back a little bit of horsepower. You can see the volumetrics stop operating. I'll go ahead and delete these. Now I super cursed the ground here, but that's okay. I'm just gonna restore it back to. I'm just gonna have to leave it alone here. Let me go ahead and bring a light here. So I'm gonna go ahead and grab a directional light. I've got Lumen on right now, so my life is gonna be made much easier. Oh no, come back. We'll just ignore that it's grass for now. It'll be okay. Okay, I've got my directional light. We need Control L. Now with Lumen, I can just very easily set up my lighting situation by holding Control L. We need our skylight. I should already have, oh, I don't have one, excuse me. Bring in my skylight. Look at that. Cool. Since I have Lumen on, I can use real-time capture. That's going to, there we go. You see how real-time capture kind of grabs the entire scene? Did everybody see how it had like a general brightness and then really brought it down? That's kind of why Lumen is oftentimes the preferred tool for a lot of people just in general when they're trying to make not necessarily make a light, but when they're trying to make an environment that has some believability or some ability to kind of like, what's the word I'm looking for here? When they're trying to create an environment that is expensive but has lighting that is going to mimic what people expect in terms of, I guess, a high quality looking game, Lumen is okay. You can achieve the same thing with light mask, but remember, you can only achieve those results with light mask after you bake. And that's kind of the unfortunate element related to baking. What I do want to talk about, at least while I still have the capacity to do so, is I want to talk about the differences in certain skies when it comes to dealing with lighting in general. Now, by default, and let me go ahead and hide my exponential height fog so that I can go ahead and show it. Yes, I know, real-time capture, sky atmosphere component. Oh, it's mad because I have real-time capture on, but no sky. So it's going to want to use the higher, brighter sky to give me something to work with. Now, the reason for that is because if we look at the actual sky, we're using our friend, at least the one that I've set up for you guys. Look, I hear my mouth. I'm using my friend, the BP Sky Sphere. Now remember, you have access to a variety of at least 2 different skies by default. Any other skies that you want, you'll have to make. While I'm talking about this in general, before I kind of wrap this up, let me go ahead and hop into there it is. I usually use Polyhaven, so I'm going to go ahead and go to Polyhaven here. And I'm going to go ahead, let's see, outdoor HDR eyes. What's a nice looking one that we can have? Oh, that one's nifty. No! Privacy badger, go away! That was nice. Alright. So, here, the problem with this is these don't tile very well. They oftentimes, the ones on Polyhaven don't necessarily tile super well. My recommendation is to just kind of live with it for now. But we do want to talk about the access to different skies and the capability to do so, since we did talk about materials and lighting last week, and there's a few things that I wanted to wrap up before I lost all that time at the beginning. That's okay. If you are using something like Polyhaven, I strongly recommend using HDR images if you are planning on using the sky or using an image for the sky. Let me tell you why. Actually, you know what? That's a question for everybody in general. Does anyone know the difference between a standard range JPEG PNG versus an HDR image? Go ahead. One more time. I'm so sorry. One more time, but louder so that I can hear your liver.
Because they're made differently. One's made differently than the other.
But how is what I'm getting at. I'll get back to you in a sec. Go ahead.
It's the HDRI. It's made in a way that's like a half circle.
You can fake that with regular JPEGs. I'm looking for one specific specific word. Go ahead. Did you? I thought you had one. HDRIs are. Does anyone know what the HDR stands for in HDRI?
High definition something.
High dynamic range.
High dynamic.
What it is basically light is typically 0 to 1 in the standard linear workflow. HDRIs can go from 0 to several thousands in terms of overall lighting quality. What do you think the skylight is bouncing off of? Do you see what I'm trying to say? If the skylight only has a space of 0 to 1 to work with, you only have about this much lighting overhead. That ain't great. The more lighting you have in a scene, the more you can do something with it, right? I demonstrated this last week by using the real world sun scale, by using the 35,000 lumens light and then having to correct it so that our eyes aren't blasted. Realistically, if you're using an image for a sky or anything else, it should be the highest range of light possible, because the HDR is going to play well with the skylight. The skylight demands that that is something that you use in order to get the full range of the lighting that Unreal has to offer. Let me go ahead and download this, and these are free. I'll grab a 4K map here. I'll just go ahead and download that. Let me go ahead and find that here, show it in the folder. There it is. I'm just going to go ahead and bring that into my file. Get in here. No! Okay, we'll have to do this a long way. Let me go ahead and create a new folder here. I usually store my folders like so. HDRs. I'm going to import this manually. Quick access. Hit open. There we go. Give that a second to do its thing. Import done. Let's open that up. All right. I'm going to go ahead and change this. Oh, it's already set to HDR. Good. Usually you have to check to see if the map itself is set to HDR, because that's going to give you the brightest, broadest range of color that is possible so that the engine can read it. What the engine is doing is it's reading this data, right? So if you want really good looking skies, don't use BP Skysphere's texture, and don't use the Unreal clouds and atmospheric lighting. I don't like Unreal's default lighting solution for its sky, mostly because it's not game capable, or it is game capable, but it's really expensive. There's no reason to have that. I really hope you guys aren't using that sky. You shouldn't be. No one's gonna see it.
I have to ask.
All right. Oh my gosh. Okay, it's fine. That's, you're probably leaving some performance on the table if that's the case.
I haven't been to these environments. I've just been doing animations.
It's okay. We forgive you. All right, that's set up properly. I don't have to worry about MIPS here. That's going to be okay. All right, so these are HDR. I can do this. Do I want to do this uncompressed? HDR. I can just set it to HDR this way. This is going to make this really expensive. That's fine. Regular HDR with no sRGB will be fine. For those of you who are curious about the linear workflow, talk to your art professors. The linear workflow basically is that all monitors tend to follow a certain type of gamma setting when it comes to seeing what everyone is looking at in terms of color. I personally use sRGB or Rec 709 when it comes to displaying stuff because that's going to give me the broadest approach to what people can see related to my work. But we're not going to sit here and talk about that. That deals with color and lighting theory. All you need to know is that Unreal uses the ACES standard, the Academy for Color something Sciences. Basically, the lighting and the color that you use are realistic to what the color is supposed to be, analogous to in real life. It's not like it's not Unreal's thought of what red is supposed to be. It's a physical representation of what the color red is supposed to be, if that makes sense. Pantone, I'm sure people have heard that company's name dropped in art circles, sets the standard for what a color is supposed to be, and then of course the science around what a color is supposed to look like is then implemented using the ACES standard. So, long story short, if you're lighting and coloring on Unreal, it's about as close to accurate as possible without modifying it. So, okay, so we've got this bad boy here. I'm gonna, oh, come on, do not, no, come on. Let me save that real quick. It's mad at me for doing things that I'm not supposed to be doing. There we go, okay. All right, so let's go ahead and, I'm gonna go ahead and do this. I'm just gonna, what's the sky material look like? It's, oh, that's right, it's, the sky sphere uses its own kind of super cursed material. Let me go ahead and create my own material and kind of demonstrate that. So this will automatically kind of improve a lot of people's outdoor environment stuff. M underscore. All right. Nope, almost knocked over my drink. Make sure I've got my notes properly set up. Oh, that's right. Forgot about that. So let me see here. I'll do it this way. It's gonna be a little bit different than I'm used to, but that's gonna be fine. Sky should generally be unlit. That's going to be terrifying looking. And so what I need in order to make this work is, let me grab this. Do I want a material expression here? I don't want that. We'll see what I need here. Wait. Let's see if I want to do it this way. This way. I might do it this way. That might make things a little bit easier. Let's do a... I'll do that. Let me go ahead and grab the actual image that I want here. Where is it? HDR. So I'm just going to grab my HDR here, and I'm just going to link it to my actual image here. Just going to plug that in. All right, that's going to be enormous. So let's go ahead and do this. We'll plug this into here, and then I'm going to give this a 3 color. I think black will be fine. So if I do it this way, and then I put this into emissive color. Why are you mad? Bound texture cube requires texture 2D. Let's see, it wants me to do it a certain way here. There we go. It wants a parameter cube and not a parameter 2D. Sorry about that. Let's plug this in. Ah, I'm a genius. All right, so let me explain kind of what I did here. This is kind of more getting into like the technical portion of creating math to make materials. What I'm essentially doing is I'm taking the HDR image, and instead of projecting it into, typically when I'm making textures, I will press T and left click to create a texture sample. Or if I'm making a parameter, it's going to look like this. It's making a parameter cube because I have the other texture selected. I apologize. Let me deselect that. There we go. So these look almost exactly the same, but the difference is going to be the subtext right there. Does everybody see the difference between one on the left, one on the right?
Yeah.
One is the param 2D, and one of them is a param cube.
Different data structures.
Exactly. So these different data structures are going to work differently depending on what they're looking for. A reflection vector is basically the direction of a reflection that is casted. This is a material function, by the way, that is casted based on a point in space, and then what that reflection is going to put onto, let's say, the easiest way to explain it is if anybody here has ever seen one of those silver garden balls that people like to put in their gardens, people believe that they increase the ambient lighting. Funnily enough, they do, because that's just kind of how lighting works. It takes that point in space, and then it projects that point infinitely in an area that can be located within the texture space. That texture that we're using, that HDR texture, is then wrapped around a cube, but the cube's edges are not visible because that's just not how cubes are displayed interiorly. Think of it as an infinitely large cube with an infinitely large vector, and the black here is really just to set your vector at world space 0, 0, 0. In fact, we don't even need to see the color of the light, or the color here. We just need the constant of where the world is located. The world, typically for any environment, is going to be located at, or the sky is going to be located at where the player is standing from initially. Hopefully, your sky sphere is far enough away to avoid things like parallax. If the sky is moving, the sky is too small, essentially. Because if the sky is parallaxing, that means the scale is too small for it, if that makes sense. This sets it at the center of the world. It casts a reflection vector from the center of the world, and then it looks for our parameter cube, which is what our image is right here. And it creates this effect. Now I'm going to go ahead and save that. Come on. Thank you. This is where it gets weirdly cursed. Let's see if I have access to a sky, because the BP Sky Sphere itself is not ideal to use because it is its own blueprint. Let me see what it's using. Come on. It's using something called an SM Sky Sphere. This is probably an engine content. Yes, it is. It's okay. I'm just going to grab SM Sky Sphere. And we're going to locate it to 0, 0, 0 by resetting its position. Oh, don't want to reset its scale. Where is it? That's fine. Let's take a look. I'm blind. It's okay. There it is. It's just scaled super tiny. Let me zoom out here so I can scale it up. Let's do... set to 0 first. Reset. We'll lock the scale. Why are you not letting me lock it? Okay, 2 can play at this game. There we go. Sorry about that. For some reason it wouldn't let me unlock it. Okay, so now that I have that selected, I'm just going to go ahead. Ooh, engine content's terrifying. Let me go ahead and go back to my materials, my sky material, and let me go ahead and apply that manually. There we go. That actually ended up working a lot better than expected. Now we can go ahead and let's go back to our actual world here so we can see what it looks like scale-wise. And then we can play around with the scale in general. What happens if I divide this by 2? Lock the scale. Divide it by 2. I said divide by 2. Divide by 2. That's actually not changing the scale all that much. I can actually run that a little bit smaller and have it look fine. What's my rotation look like? Okay, that'll be fine here. Now this works reasonably well if you don't plan on doing anything else with the sky in general. It gives you just kind of like a position of kind of working with your HDR image, but you can see that the direction of the sky doesn't necessarily match up the direction of the lighting. The way that I kind of solve that is by kind of eyeballing it. Close enough. And there, now we have an environment that is adhering to whatever our sky sphere is doing. We don't have to worry about whether or not it's expensive or not. It's giving us exactly what we need, plus the environment that we've already created inside this UV parameter. So you can see that our HDR is working well, and in fact it doesn't give us that horrible doming effect. If you want moving clouds, however, unless you make your own blueprint for it, you're kind of left without them. You can add the cloud behavior by adding the volumetric clouds, but the problem with the volumetric clouds is they don't really match up to the actual clouds in general, but a lot of people don't really care whether or not they do. I will say that the clouds are driven by a texture. Do you want to see it? You don't want to see it. Remember how I showed you guys material instances, and the material instances have all these parameters? There you go.
Whoa.
Play around with the parameters and it'll give you different behavior. I'm sorry, the clouds are in like a bad spot here. It'll give you different behavior based on what you're trying to do here. There's a lot of different things that you can control. Oh my gosh, wind vector, for example. Let's see if I crank that up. There you go. Not that you'd want to do anything like that, but you get the idea.
Clouds become God rays.
Essentially. The other thing to talk about is that the inherent position of the light also has access to sun shafts. If I look in the directional light and I scroll down, there is light shafts. In fact, let me go ahead and see if I can demonstrate them. I'm going to put the light in a position where this demonstrates it as much as I can, because this is going to be kind of hard to display. Let me turn this on. There it is. Hold on. There we go. The clouds are blocking it. Go away, volumetric clouds. I don't need you right now. You're trying to display something here. I discourage people from using the... There we go. Yep. There we go. So now we have light shafts. Notice that this is not using the volumetric function of the exponential height fog. This is the most expensive sun shaft and lighting that you can get. So there's two ways to get to sun shafts. Either through the exponential height fog and using volumetrics, or using the light shafts function of the direction light. Mr. Figueroa, can we use both? Do not use both at the same time. It is way too expensive usually. Mr. Figueroa, why does the light shafts also have access to sun shafts? And why does the exponential height fog also have access to light shafts? It's not that exponential height fog has access to sun shafts. It's that the exponential height fog is the gateway to volumetrics. This is volumetrics, but very constrained to only one thing. That is the sun, right? The volumetric itself is confined to the actual sun. Depending on the overall look that you want, you should pick one, but not both. Volumetrics is almost always going to be a little bit less accurate than using the sun shafts inside of the actual directional light. But don't use both. And look, this is the most expensive way to get your God rays. There are better ways, there are faster ways. Just put a God ray on a texture and then just stretch that out. That's going to be the cheapest way. The most expensive way is going to be this way, but you can see that this is giving us some really decent light rays. We can also set like the different brightness or the different bloom tints so we can see what the bloom tint is doing, so we can change the behavior of the bloom itself. I personally like Goldblum. No, not Jeff Goldblum. But Goldblum when it comes to lighting, because that's kind of what your eye sees in general. But it's just going to depend on what you want. I'm going to disable that. Okay. Let me talk about nighttime. Now, the easiest way to do nighttime to kind of illustrate it as a concept is, one, I'm going to get rid of my sky sphere. You can, in fact, borrow it. We don't like Max in this. Tell her how we hate Max. Yeah, thank you. That is the truest thing I've ever heard in my life. Now, the reason why I'm going to use the BP Sky Sphere to simulate a night is, well, I didn't download a night HDR image, so there you go. That and the BP Sky Sphere gives you a little bit more room to do stuff when it comes to your overall lighting. Again, we're not doing a lot of texture making, we're doing a lot of exploring of the system that gives your environments what the player is going to see. Lighting is 9/10 of the work, right? How your environment looks is going to be entirely on lighting, and it's easily the most expensive thing that you can do in your game. Just add light. The moment that you have lights and shadows, it's going to be one of the most expensive things that you have to deal with. So learning what you can do with it and learning how you can kind of get what you want out of it is going to be important. So I'm going to make sure that the BP Sky Sphere I've selected is linked to my directional light. Let me refresh that material. Link to my directional light. And I'm going to make sure that colors are determined by sun position just so that I have it. And I'm going to see if this is actually working. Actually, let me Control Z to deselect that. Control L. And put that way and see if the material refreshes. Yes, the material does refresh. Okay. So this is a little bit easier if you are using light mass or if you are using the BP Sky Sphere if you are trying to get the behavior of the night sky. Let me go ahead and do it this way here. So what I'm going to do is I'm going to take my directional light. I'm going to set this to 0 lumens. Actually, I'll set it to, let's set it to 20 right now so I have an idea of where it's pointing. And I'm going to go ahead and take my light and manipulate it here. So let's go ahead and I'm just going to point it straight up. The best that I can. Good enough. This is going to give everything kind of like this terrifying underlighting, but that's okay. I'm going to set my directional light to 0 lumens. My skylight is also contributing a significant amount of light. So I'm going to take my skylight and I am going to grab my, where's my distance? There it is, intensity scale, set you to 0. Alright, and now I'm going to refresh the sky here. There we go. Now, as you can see, does everybody see what's messing with our environment right now? Everybody saw it just happen, right? What's the thing I typically always disable when I'm working with lighting in general before I turn it back on? The adaptive eye, the exponential, or the adaptive eye, or the auto adaptation, the eye adaptation. That's because it kind of throws off the overall vibe, and it gives you the wrong impression of what the lighting is actually physically doing. I'm going to go into unlit mode so that I can see what is actually physically happening here. And I'm going to, let's ignore that grass. I'm going to go ahead and create a post-process volume, same as always, do that. I'm going to immediately go to unbind it, infinite extents, and then I'm going to go into exposure, min and max EV, I'm just going to set to 1 and 1, and then I'm going to go back to my lit mode to see what it's actually physically doing. Come on, do not be angry with me. There we go. Now, I don't have a moon texture, but this is where you can go out here and essentially just kind of put a giant cookie or something. We call them cookies when it's just a flat 2D image. This is where you can start designing your environment to kind of do exactly what you need to. When you're creating environments, the majority of the stuff that you actually make is going to be, one, in the environment that is playable, but two, also in the backdrop. Does anyone know or has heard the term backdrop before? Can you explain what it is? Well, you know what it is. You're in the class. Or you were in the senior class. I don't want you to answer. Go ahead. Go ahead and who wants to give it a shot then? Go ahead. What's a backdrop?
Something you drop in the bag.
Give them a prize.
If the player space is this little area right here, the backdrop is everything that hides the fishbowl. One of the most important thing to understand about games development in general, how to hide the fact that we do not have an infinite space to work with. It just, go ahead.
Why is there so much detail behind the areas that you can't see?
Believe it or not, there's not a whole lot of detail. That's actually pretty bad. That's play height. That's a very low resolution texture.
I feel like the other half about it still.
One more time, just a little louder.
You still need the other half about it. Like, behind that.
Oh, as in like, why are we rendering the back of this?
Yeah.
Because it's a landscape. It doesn't cost very much to just kind of render the whole thing. In fact, you'll learn about landscapes here in a couple weeks. It's actually not a good idea to cut a landscape up unless you absolutely have to, because Epic has a very specific range of landscape sizes that they want you to use. It's also in the landscape technical documentation. If you chop up a landscape, you still use the whole landscape cost in RAM. So just use the whole landscape. You get what I'm saying? Yeah, it seems kind of backwards, right? It's like, why would it cost more to use, why would it cost the same to take a landscape and cut it in half? That's because, funnily enough, what you're not able to see, and what I can demonstrate in a future lecture, is what the camera isn't seeing is already automatically culled. It's weird to explain that it is, but what the camera isn't seeing isn't actually rendered. I would have to, let me see if I can freeze it. I don't know if I have the character possessed. I do. Let me simulate here and see if I can freeze this. Simulate. It's not letting me freeze the rendering. Freeze, mouse cursor. It doesn't want me to do it while simulating. Essentially what is happening is when we are not simulating or when we're not seeing something, it's already technically automatically culled. It's just not visible when we're observing it. We'd have to freeze the rendering, and then I'd have to it's trying to update the renderer as I'm freezing it, so it's showing us the back face of stuff. It automatically colors. That's just kind of what Unreal does. So if you cut a landscape, this is actually a landscape object. If you cut that in half, it still costs you the whole landscape. So just use the whole landscape. Do you kind of get what I'm saying there? Like you already paid for it. You might as well not cut it. In fact, cutting it actually has a little bit of a cost to it. So arguably, you render it and then unrender it by cutting it. It costs you the original cost plus the cost of the cut. So yeah, but I hope that answers your question. Backdrop's really important to just world building in general because it hides the fact that we can't actually get out here. As you can see, a majority of this environment is actually just the same geometry, but the actual play space being down here, and I just rotated that on accident, is what kind of makes this environment work. Let me go back to my lit mode here so I can see the environment here. Okay, I still can't see, but what I'm going to do is I'm going to pump up the skylight until I get something that looks okay. Let me just kind of... Okay. See what I want. Probably a more gray value.
I think it's stars. Is that
I'll show that here in a sec. Go ahead and do 35 here. 50. Let's see if I just get more lighting. Let's hit play. Let's simulate this real quick. Stop that. Come on. It's a little bright still for nighttime, but you get the idea. Again, I would argue that there's just as much luminosity in a night scene as there is in a day scene. It is really just filtering and building the environment to look as though it is nighttime. The reason why I'm using the BP Sky Sphere in particular here is because the BP Sky Sphere has the capacity to use a directional light to control what the sky is actually doing. So remember how I pointed the directional light straight up? That's implying that the sun is on the other side of the planet. When I update the BP Sky Sphere, the BP Sky Sphere has a function that lets you use a night sky. You could just build a new level with a different, with your own night sky, but this is kind of like a quick and dirty way to actually do it. I'll get to your question in a sec. The Sky Sphere, because it's using the BP Sky Sphere, has the capacity to use different things, like we can increase the star brightness.
hyperspace?
Unfortunately, this does not have any constellations in it. Question?
So why is there light? The sun is like below the map, shooting up. Why is there light coming down still? How can you see the scene? Wouldn't it be pitch black?
The skylight.
Skylight, okay.
The skylight works in conjunction with the light itself,
And that's-
but the skylight is reflecting what is in the sky atmosphere. And right now all we have is a BP Sky Sphere that is emitting some light, so the skylight looks straight up, senses that the sky sphere is there, and then recasts the light downwards. The sky sphere is, the skylight is basically magic when it comes to like just creating the depth of lighting that you kind of expect in most games. They work in conjunction, and they should almost always work in conjunction. A skylight does not actually work if you do not have a sky or anything to capture the lighting. So if you don't have a sphere at the very least, you are casting into the infinite darkness. There's no sky. It has to have something to reflect off of. In this case, it's reflecting off of the geometry that is the sky sphere that's part of the BP Sky Sphere.
So it's reflecting the directional light, which is pushing up to the bottom of the world?
The directional light is currently set to 0. It is not reflecting anything. It is basically averaging out the light intensity that would exist from the highest portion of the atmosphere to the ground level. And it adds light to what would be a dark environment. That's why you don't just use the directional light by itself. You use the directional light and the skylight. The skylight is basically the additional GI simulated of what the atmosphere would add to a scene. It's kind of like the difference between a cloudy day and, say, like a misty day. Your skylight influence plus the exponential height fog is going to have an influence on your lighting, whereas your directional light is typically always going to be, especially if it's outdoor, is going to typically be just, we can't turn down the sun. Like we can in a game, but typically it's going to have a very set value. The exponential height fog and the skylight are how you massage those values to give you the effect that you're kind of looking for. Now what we're doing here is we're cheating. No, I wouldn't call it cheating, but look, if you need night, what is night? It's not the sun placement on the other side of the world, right? Are we on the other side of the world? No, but the directional light thinks so, because that's how the BP sky sphere works. And so by using that, setting the directional light to 0, so we're not actually using any influence of light from the directional light. We're just using a directional light to set the BP sky sphere to the correct position. Because if we are using colors determined by sun position, man, it looks really weird if you have that turned off like that. However, we can use the manual settings to customize our own sky. Come on, a little more clouds. A little less clouds. More stars. Faster clouds. That's too fast, but you get the idea. Now, the reason why this works reasonably well for most student projects is because it's a one-stop shop for all the things that you might want to be. And in fact, if you're interested in looking at the BP sky sphere, a BP is anything listed as BP is in fact a state blueprint. It has code that makes this work. We'll cover some blueprint stuff, and then it'll be pretty obvious as to how these are assembled. And then the rest just kind of becomes the process of understanding kind of how you can see where it's rotating around the main pole at the center. So the expectation is that you're not looking straight up. It's just, you can see it's just a panning image. It's not anything special. You can build something like this yourself if you really want to. But that's what we're doing with the directional light. We're cheesing the directional. Well, I'm not even using the directional light anymore at all. I've broken that connection, and I set the colors of the sky manually. You could do the same thing if you find a night sky in the HDR with maybe a constellation that you might like, and go from there. There's a bunch of different ways that you can do it, but the most important thing is two important things. One, does it look like what you want it to look like? And two, does it run well? If both of those are yes, you're doing the right thing. Oftentimes, making something in a game, and these two will probably know because they're in the senior class, is making it close enough. The simulacra of the thing is more important than whether or not it's technically correct. Because one, this is not a sun, it's not a real sky, those aren't real clouds, these aren't real buildings, and this is not a real place. It is irrelevant at that point how it works, because ultimately what we are trying to do is fake it. We are trying to fake the behavior. We'll go on break here real quick, but let me go ahead and see if I can what is the name of that game? Hold on, let me give you a better idea of that, and that closes off our discussion on materials and lighting, at least the stuff that I wanted to cover. Let's see. Here we go. I always really like showing this one because a dev actually posted this a while ago. This kind of gives you an idea. Okay, so I can't stop this. It's a GIF. There we go. Man, that sky is trash. um,
Is that early stage now?
no, this is production. Just to kind of wrap up kind of the world building slash, we'll revisit world building in a few weeks again when we're learning how landscape and how distance culling optimization works. Bottom right is the actual in-game footage, what the player is seeing when they're what the player is seeing when they're actually playing the game. The big screen is Unreal 4. Pretty generic looking, but you get the idea. Now, I'll explain what's going to happen here, but I'll let this play through once, and then I'll explain it piece by piece what's actually physically happening. I wish they gave me a... Hold on, let me... Oh, whatever. I'll just let it play all the way through. I'll let it play twice so you can look at both the background and the foreground, or background and the game footage. We're not flying a ship, and it's not actually a planet. We're just faking all of it. The ship doesn't actually go anywhere.
Wait, what?
I'll explain it all here in a sec. Okay, so initially, the ship is going to be moving through the environment to kind of create the impression of movement. That's what you're going to be seeing down here in the bottom. We go ahead and play.
So it's a fake loading screen?
I wouldn't say it's a fake loading screen. You can still just, the character doesn't move, so the character's just watching and there's dialogue happening. But this is kind of like the planet transitions, right? Let me go ahead and do it this way. What you're seeing right now is during the playthrough, and they're using Sequencer for this, we'll talk about Sequencer in the future, is as we're moving through the space, that sphere becomes the sky, if that makes sense. I mean, what is the sky if not the... I can see some of the sky through that window. What if only the portion that I see in the world is actually real and the street doesn't exist because I can't see it? Question.
So the sphere kind of works like a light portal, or not exactly the same way, but like the way the light portal works for lights, like that sphere is like...
No, essentially we trap the character inside that sphere, and once we render it out, the world is whatever is inside the sphere. We can put whatever texture, whatever lies we want in there, it can actually work. In fact, let me show a little bit further. Oh. We stop rendering the lighting because the transition of what is the most lit object is now the sphere and not the environment. So now we're saving a little bit of performance. Once the sphere becomes opaque enough, we do not actually need to continue to render the rest of the level. We can just stop that. And if you notice, it was indiscernible what was happening inside the screen. You just can't see what's actually physically happening inside of the craft. You just can't see it. So right now, the world is basically just that sphere around the ship, and the camera is just kind of observing what's through that window. Let's keep going. That's just a texture, by the way. That texture moving is just a texture that's panning. Okay, there's our stars. The stars are actually rendered on the face over here. It's kind of hard to tell, but you can see some of them. That's just a cylinder with a bunch of stuff on it. That flash is the Niagara effect. That's just another cylinder inside of another cylinder that's moving past us real fast. Well, it's not moving past, it's just the texture is panning real fast.
What year was this development?
2018, I think? Now they're using a shaped object here probably to give a little bit of depth, but that's all that really is. Remember, my point about this is the simulacra, look, it's not really nighttime, it's not really daytime. Ignore the predispositions to what you want to do. Most new people to Unreal want to create a one-to-one environment. That's not how we do things. We are trying to fake it. We're trying to make it look like a thing. No one's saying if you have a light source that you can only have one light. Oftentimes I turn off the shadows from multiple lights and then create a lighting array that is going to light my environment. But really there's only like one emitted light in the environment. There's only one light in the game. Or maybe there's a bunch of lights that don't cast shadows. I need them to actually emit light, because otherwise a little point light in the scene is just not enough. There are no rules. The only rule is, does it work and does it perform well? Does it work and does it perform well? Those are 2 rules. That's it. The rest is really just making look. If you need to create a shadow somewhere, no one's stopping you from physically making a shadow somewhere. No one's stopping you from putting another light that only affects one object that creates a shadow. You don't want to do that, that's expensive, but there's a time and a place for it, right? What I'm trying to illustrate with this is, don't think about it, lighting, texturing, world building, as though you are trying to build a 1-to-1 scale world. If you are trying to do that, you're not messing up, but you are missing the toolkit. The toolkit is supposed to fake it, right? There is no infinite environment. There's no environment beyond what is already visible. It doesn't matter if the camera is trapped somewhere, then that is the world, if that makes sense. If you're hiding the credible edge, then there is no edge. If you're hiding the position of the sun, then there is no sun. If there's only one emitted light but we can still see, congratulations. I can't see at night, and yet somehow in video games we're expected to understand that it's nighttime. We can't really see that well at night. That's not what we're trying to simulate. We're not trying to simulate nighttime, we're trying to simulate night vibes, right? So understanding how to achieve that with the tools that you already have is more important than trying to achieve the 1-to-1 simulacra of what you're trying to do. Once you understand that process, or that, hey, I'm not trying to create the moon, I just need to put something in the sky that looks like the moon. Congratulations. You figured out that the engine is capable of doing things that you want it to do and not necessarily has to be 1-to-1. So let's go ahead and take a quick break. When we get back, we're going to shift some gears into some blueprint stuff, and we'll just keep going. All right, so unfortunately, I'm going to be punting the blueprint assignments next week. That's okay, that's just the way that it has to be. I'm going to chain this, I'm going to be buying my own HDMI cable to make sure that I don't even think I have a female to, I'll just get one and then we'll see if we can use a projector next week. That way, they should be providing one, but it's fine. We'll solve that. I'll make a complaint. Anyways, we'll do a hello world and we'll kind of illustrate some very generic intro to blueprint concepts. But in order to kind of do that in general, I need to talk about component stack. That's going to be kind of new for everyone. So we're moving away from level design, world building, so on and so forth. If you want more level design, take my level design class. We do nothing but level design. In terms of prototyping, you should probably take my level design class, apparently, if you like putting skylights and...
When you offer it again?
It's only offered about once a year, typically going to be in the fall, but there's no telling. People have to have interest in order for it to be fired off. That's more your traditional level design. I'm only giving you a hard time because you wanted to put a sunroof in the classroom. Go ahead.
Are they prerequisite classes for level design?
That's a question for the registrar, unfortunately. They keep changing that on me. I think, funnily enough, Game Design 1 is a prereq for...
Environment design.
Is it? They might have changed that on. They might have changed that on me. That's a question for them, unfortunately. You're also, folks, welcome to crash any of my other classes if you want to kind of stay in. But if you crash any of my production studio classes, I'm going to make you do work. I think that's kind of, these two understand, if you crash any of my production studio classes, I'm going to make you do work for us. So most people just don't stay for more than a couple of weeks because of that. Okay, so let's go ahead and move past the, excuse me. Let's go ahead and move past the, I don't want to say creative portion, but let's start to kind of look at a little bit more in relation to, grab my note here. There it is. In relation to what is possible with the Unreal Engine when you're looking at it from a more technical mindset or technical approach. if you want to learn more about gameplay scripting, take the gameplay logic scripting class. That's going to be a question.
Okay, is that also a class that's only available to people who are interested? Or?
That one is typically taught a couple times a year. It bounces between me and the other professor who's teaching it. It just really depends on what you want. That's kind of like by a need class. I think if people register for it, then it is hosted. But that's more of a question for Max, unfortunately, because
Okay.
he's the department chair. So.
For either of those classes, the level design or the gameplay scripting, how would you, like, do you have to email the registrar to let them know you're interested, or like, how does it?
I would talk to Max about that. I wish I knew when they pop up because I'm told that they're available to be registered and then no one registers for them. But I'm inclined to believe that they just don't offer it. I don't know. I don't know how it actually physically works.
Alright.
I wish I had better answers for you because this is a broad class. This is kind of like because most of you are still getting used to it. Level design focuses on level design. So it focuses on one principle of building a thing to test it, right? Adding mechanics and kind of going from there. It really just depends on kind of what you want from it in general, but you get the idea. I don't know when the class is actually being hosted.
Okay.
I know I get pinged to teach it every so often, but it's by a need basis. So if there's no interest, then they don't host the class.
Okay.
But if there's no interest, then how do they host the class? Talk to Max about that. He'll be the best resource for that because he works with the registrar to set up what the class is supposed to be. So, if you want to take gameplay logic scripting, that's going to focus more on understanding object-oriented programming and object-oriented approaches to programming. We only focus on creating gameplay approaches and gameplay logic in this class, and because of that, we're going to focus on using blueprints predominantly over C++. Game Design 2 will sometimes include some C++, but because we don't have like a fully dedicated staff that teaches C++ exclusively, it tends to be kind of one of those things that's like a need-to-know basis kind of stuff. So bear with me. I will say a few things before we actually get into it related to blueprints, but for now, I need to talk about a few things related to component stack before we even get to the idea of what blueprints is supposed to be, and then we'll get into our hello world. So what I'm going to do is I'm going to launch a new fresh project. It's going to be great. All right, games. We'll go with blank this time. This is where you can decide to set your IDE up for Blueprint or C++. If your IDE is set up for C++, all it does is it makes C++ objects that immediately open up Visual Studio. So you have to have Visual Studio set up in order for this to actually work. We'll use Blueprints for now. It doesn't require Visual Studio. And we'll talk about it when we get there. So I'll do Blueprints for now. Desktop maximum, no starter content, no ray tracing. I'm going to call this Intro to Blueprints 203, and then I'm just going to go ahead and hit create. All right, we're going to let that cook down. File new level, basic, create, wiggle, Control S, new folder, maps, maps. To do that, I'm going to hide the engine content. Mr. Figueroa, what's the engine content again? That's the stuff that is part of the engine that is shared by everything in Unreal. It's great to use, but don't mess with it too much. I use it a lot because I have respect for it. It's like walking through a field of knives. You just want to be really careful with what you're messing around with in there. And if you mess with anything, you want to make copies. You don't want to affect the original file because everything uses the engine content. Anyways, let's talk about component stack here. When an actor is created, and I'm just going to go ahead and create a basic actor here so we can go ahead and use something where we can see it. When an actor is created, an actor is just a container. I've told people to ignore this portion of the viewport for now when we're working with the details panel. But everyone always glances over this area without realizing that the component stack or the component tree, or some people call it component tree depending on what you want to call it, is essentially how the relationships between objects work in Unreal. I'm going to go ahead and duplicate this object here. Now this could be any object, and in fact I hate duplicating. I always do Alt and left click drag. I'm really bad at this pass. There we go. I'm going to go ahead and rename these objects by pressing F2, and I'm going to call this object 1 and object 2. In the outliner, objects can be childed to other objects. Does anyone know the difference between parenting and childing of any objects in general? I'm sure you've heard that term before. Can anyone tell me what the difference is? Kind of a trick question. Go ahead.
Parent the original one and the child is copies of it.
Those are called instances, technically. But you're on the right track. I like that. I like that you're thinking about that. I saw your hand go up.
A child inherits data from or information from the parent, but it can have its own information on top of it, right?
True.
Okay, so in Maya, a parent controls another object.
Essentially that. Basically, everyone is right within different capacities. Parent relationships in Unreal change depending on the context of where this relationship happens. A parent relationship is a main object to a lesser object. A child relationship is a lesser object to a main object. There is a difference. If someone says, I am childing it to something, they mean they are putting it under the stack so that behavior is translated to the child. If they say they're parenting something, it means that something is being attached to this object, and that object is the controller object. Some people use the term interchangeably. I just want everyone to know that I try to use the correct term, but because it's such a broad term, a lot of people consider parenting or childing as the same thing, but they are not. If someone says child this thing to this, they mean that that should be the sub-object of another object. If someone says parent this object, they typically don't mean parent this object, they mean child this object to another object. Go figure, you're going to want them to be specific. In the outliner, objects can be parented to each other. For example, we have object 1 and object 2 in here, and just so I can keep this fairly straightforward, I'm going to close the world settings and I'm going to move the details panel so that we can see the fullness of the details panel in the outliner alone. I'm going to child object 2 to object 1 just by left click dragging it on top of it. In Unreal, a child or parent relationship in the outliner is purely positional. So now that we have object 1 parenting object 2, this relationship is positional. Now, notice that the details panel does not acknowledge the child in any case, but the outliner acknowledges the position of the child underneath object 1. We can move the child individually, but the parent now controls the behavior positionally. This is the only behavior that exists this way in the outliner. You only have access to parent relationships in the outliner. It's for ease of use and construction. I'm going to go ahead and unparent, or rather unchild object 2. See, now we're getting into it. I'm moving the child, and therefore I'm unchilding, not unparenting. You unchild, not unparent, because you can't technically unparent in Unreal. You can only remove child from the parent. You can't remove the parent from the child. That sounds really terrible, and I hope this recording doesn't get cut up. Question?
You said that it's positional. Does that the size is different from that, right?
Yes.
Okay.
It's purely positional. Scale is separate.
Okay.
Rotation.
Also separate. Actually, let me before I say that for sure, it should be separate. But let's see. Nope. It's part of its position, its world position. So it is. Oh wow, they changed that. Excuse me. I'm a liar now. It's based on its global position. It did not used to inherit that behavior. So it seems like, yeah, They changed that on me. It looks like it inherits both the X, Y, and Z as opposed to purely positional. Well, that makes me look like I don't know what I'm talking about. We typically don't use this because all it is just a relationship that is purely actor to actor, right? Let's talk about component stack as I unchild this. There we go. Component stack deals with the way that code understands the way that individual actors are. This actor is actually two components. Both of these actors are a named object and its component behavior. In this case, object 1 is just the name of the object. It is currently the state of this particular object, and the second part is going to be typically the contents of this. As you can see, the static mesh component contains typically things like its geometry and its texture. Objects can be added to components by way of adding components in this stack. I'm going to go ahead and assemble this very quickly and just kind of show this. So what I'm going to do, just kind of get rid of that, I'm going to go ahead and show, let me go ahead and grab a cylinder, and I'm just going to assemble this ugly just so people can understand this as a concept. Components are important because components can be referenced as variables. Variables are important to Unreal because variables is how you do anything. So I'm just going to go ahead and just create that. I'm going to create a cube. It's going to be a terrible flashlight, but you get the idea. Shapes, cone, move that up, top view. Come on. Perspective view. Good enough. Now in the outliner, these all exist as an object. Now, the problem with this is just three separate actors. There's three separate instances, three separate actors, three separate costs. When you have a similar object that's set up with components, an object's components are a more optimal way of adding, let's just say, variables to an actor to be able to create more complex objects. Unity folks will know this as a prefab. Does anyone use Unity? They call them prefabs. We call them blueprints. It's essentially, but a blueprint is not a prefab. A prefab is basically just a stack component. A blueprint in Unreal can contain behaviors that speak to the gameplay logic engine. Go ahead.
So the thing you just built, the engine treats all three of those shapes as like separate objects. Right?
Exactly, they're separate
Whereas
objects.
The thing you're probably about to build, it treats those as one object.
Yeah, I'm about to build. Yes, I'm going to do exactly that. So in this case, what I'm going to add to this cylinder here, and I'm going to go ahead and call this something like. I'm going to go ahead and add a. We can add static meshes directly, but what I'm going to do is I'm going to add a cube because that's a basic cube that already exists. We can call this something else. And then I can scale this as I need to. Shoop. Shoop. Position. Drag. Cone. Position. Drag. Center. Scale. Scale is always a little weird when you're dealing with this kind of stuff because scale is not going to be scale is based on the individual position of the object. So there we go. Despite the fact that these objects look similar, this is one object with several child components. Go ahead and rename this one. Oh, I childed the cone to the button. I'm going to unchild that. There we go. I'm going to call this This is now one instance of one actor, and this is a more optimal way of creating assets in Unreal, because this is what is referred to in a lot of cases as a prefab. A prefab is essentially a single instance with multiple components. It is an optimal way of creating an object with multiple elements that can be moved around, and it's not grouping. Grouping is expensive because grouping is another process on top of an already existing element. Granted, you made your trees in the most cursed way, and Professor Grant knows now. That's a new one for me. But you get the idea. The thing that makes objects like this fundamentally different than this is behaviors can be added via component tasks. Or rather, in this case, if I really wanted to do something like, I don't know, I'm going to add just a rotating movement to this behavior, and let me see if it'll play. No. Put me in the wrong bit. Oh, it's going to give me a warning. Mobility is can't move. Let's check that again. Oh, hey, look. Static mobility. So I'm going to go ahead and set it to movable, and I'm going to simulate here. I don't want to move different locations. Oh, it's rotating in the wrong axis. That's okay. That's hilarious. Let me see. Let me rotate it in an axis that is going to be more fun. Let's do 180 this way. There we go. So the benefit of adding or being able to create elements from components is not only are you able to add variables because it's all you're adding, but question.
Could you do that to lights?
Yes, because lights are also part of components.
So you can make a flicker, hypothetically speaking.
With a blueprint, you can do any kind of behavior that you need to, including things like flickering. You would probably create a timeline, but you get the idea. In fact, let me go cram this light up. Do lumens, cram that light, give it a color, hit OK, and then we're just going to simulate. There we go. Now we've got a raise. Is that light set to dynamic? Hold on. Let's make sure that that light itself has the ability to actually become dynamic. Yep, that light is movable. Why would this light need to be movable? Because it's actually physically moving. This sets up the correct mobility settings for objects that have mobility in general. Go ahead.
So that rotating movement component you just added, is that what would normally be used in like an RPG game if they wanted like a floating item on the ground to like rotate, or would that be like manually programmed?
Could you do it manually? Yeah. Rotating movement is a simple utility that does the exact same thing.
Right.
I usually.
So would that be the preferred method to use rotating movement? One like I don't know, Minecraft is like rotating. Not that's a different game, obviously.
If it does nothing but rotate in place, if you need anything else, like it speeds up when it gets picked up, then you'll have to use something other than rotating movement, and that's typically just what's called a rotator. And then you can modify the rotator's speed during runtime, firing off events, etc.
It's a different component?
Yeah.
Okay.
So there's a variety of ways that you can do this. Now the reason why I'm talking about Component Stack is Component Stack is the gateway to Blueprint object creation. Let me show it this way. Blueprint objects are different. This is fundamentally still just a prefabricated object. What if I make a new level? What if I make a new level right now? What happens to my, let's call it a prefab, even though technically Unreal does not like using that term. What happens to my prefabs? Where do they go? Exactly. Prefabs, in this case, are married to the level that they're created in. So what's the point? If we save it, it's saved to the level because it's saved to the level logic. The next step from understanding individual objects to complex prefabricated objects is to understand the idea of blueprints. I'm going to go ahead and create a new folder, and that brings us to blueprints in general. Blueprints exist in several states. There are blueprint objects, which are basically complex components with variable behavior, and blueprint logic, which is code that does a thing. Blueprint logic can exist in multiple states, such as in-level events or the level blueprint. Let me start by showing a blueprint object, and then we'll move towards level blueprints, and then I'll show our hello world, and I think that'll be our time for today. So, blueprint objects are easily made by right-clicking the slate, and funnily enough, you have access to something called a BP class. Let's go ahead and click on BP class here. These are the most common classes: actor, pawn, character, player, game mode, actor component, and scene component. Everything on the scene that can be seen on the stage is an actor. So Mr. Figueroa, why do we have pawn and character? All characters are actors and all pawns are actors, but not all actors are pawns and not all actors are characters. Character and pawn are differentiated predominantly from the need for a bipedal motion. If you are using character, it's because it gives you biped access and things like gravity, things like speed, movement components, so on and so forth. If you are using pawn, pawn is just something that can be moved on screen. This is like the difference between using a character and, like, say, making a flipper for a pinball game. It's not a character, right? It's still a pawn. An actor is the most generic form of a blueprint and is typically the most used. Go ahead.
So like an actor would be like maybe a set piece, like a tree or something. Would that be considered an actor?
An actor is anything that can be on the stage.
And then a pawn could be like a power up or like item or something.
A pawn is anything that can be possessed. And I'm not talking about like the spirit of the Lord. I'm talking about like possessed by a player controller. A pawn is anything that can be controlled.
So you can control a pawn even though it doesn't have like bipedal movement or gravity, or
Exactly. A pawn could be like a little ship that's moving around.
okay.
Or something that's moving on screen that doesn't have character movement. A character specifically is for bipedal characters. I think it even says that. Character type is pawn that includes ability to walk around. There you go. Walk around and moving around are two different things.
So is it like actor, pawn, character in the sense of complexity?
Yeah, you could say that. Although you can make a character from an actor, it just starts you off further down the line, if that makes sense. If you're gonna make a character that moves around, you should start with a character.
Yeah.
It makes your life a little bit easier. We're gonna go with the basic form of this. We'll talk about each of these as we start building our basic game next week. Let's go ahead and create an actor here. And I'm gonna call this BP my first BP object. I'm gonna go ahead and hit enter. I said I'm gonna hit enter. Welcome to the Blueprint interface window. The Blueprint interface window has similarities to other portions of the engine, but over on the top left we have our component stack, or it's basically the components, the same thing that we looked at. We also have the Blueprint window, which contains things like commonly used events. We have functions, if we make any. We have variables, we have macros. We're not going to use macros or any of those complex event dispatchers. That's going to be for gameplay logic scripting. We're going to be using this to kind of create object behavior. Over on the right is the details panel. That's really all you need to know. And inside of the middle is going to be your slate. We also have access to construction script and the gameplay event graph. Both of these control the behavior of what the object is doing either before we press play or when we press play or an event actually physically fires off. If we are to look in the viewport, for example, I can just go ahead and create this. Like, for example, let's go ahead and do the same thing that I did earlier. I'm going to go ahead and add a cylinder. Do not lag on me. I'm just going to scale out that cylinder, rotate it 90 degrees, scale it down a little bit. I'm going to add a cube. We have access to basic shapes, so it should be fine. Cube, oh, I did not mean to rename the cube. I named it R, it's fine. Now, the cube is currently a child of the cylinder. That might not be something that we want. In fact, let me unchild it. There we go. I'll have the default scene route selected. I'm gonna add my cone. Salute. Move over here. Close enough. And I'm gonna add my light. Nope, directional light is bad to add. Did you see how mad it gets? Let's add a spotlight.
Are you making a flashlight?
Yeah. And we'll move this in this position over here. And if we want, we can go ahead and child the position of the light to the cone. We can go ahead and create something like this just very quickly. I'm just going to crank up the lumens, change the color to a color that I can see, and then I'm going to make sure that the entire object itself is movable. And what the heck, let's add a rotating component. Just like what I did. Rotating movement, 180, 0. I'm going to simulate in this scene right here. Good enough. Make sure my spotlight is movable. We'll save that. I'm going to compile that just to make sure that it's code complete. And now we have an object that can be reused over and over.
In different levels, correct?
Exactly. Now if I hit simulate here, you see that the objects are going to actually move. This is like a rave now. Now, because a blueprint object is enshrined as a file, that doesn't mean that the object is permanently set with those behaviors. If I really want to, I can change the behavior of the rotating movement within the object itself.
And that only changes that one instance, right?
And that only changes it for one instance. I'm going to save and hit play. So notice that I doubled the speed of one. The original is always going to be left alone. So if I drag out a new one here, it's going to be at the original rate. Modifying objects that are already set in blueprints in the level do not save up to the blueprint. It rolls downhill. So objects that are enshrined as blueprint objects are protected. We now have an asset that we can use in multiple levels. If I were to move to a different level, it doesn't matter if those prefab objects stay behind. This is why I tell people typically don't bother with creating prefabs. Just create a blueprint of your object that you need. Now, I've got 8 minutes to explain this as a concept. Okay. Now that we've explained component stack and kind of how components operate, the thing about components is individual components can be modified after the fact. So if we really wanted to change the color of the light in here, I could go ahead and change the color of the light right there without modifying the original blueprint. The original blueprint is still going to have the original color that I set in here. That's our version of the prefab. The prefab that we use is called a blueprint, and a blueprint has functionality baked into it that cannot be altered on the level. Well, it can be altered on the level, but it does not alter the original asset, if that makes sense. And not only that, this asset can be used in multiple places. This is where you create a door with keys. This is you create an asset that is going to be used multiple times. This is not just limited to creating a reusable asset. This is expanded to be able to create other assets with logic that do a thing. So let's say a little fountain that fires off when the player gets really close. We can use that multiple times, multiple places, and we can create that behavior in here. That's what the events are for. We'll talk about events some more next week. What I want to do is I want to start talking a little bit about the actual logic of blueprints in general. I'm going to create a new level here. And I'm just going to go ahead and save that as all right. Blueprint objects are fundamentally different from something we refer to as the level blueprint. The level blueprint is a place that I usually tell people that is safe to create behaviors that are going to happen only on this particular level. I'm going to go ahead and create my hello world now. In order to access the level's broad blueprint, we have to click on this button right here. This is your list of world blueprints available. We can just go ahead and click on that. And as you can see, we can go ahead and open the blueprint class, or we can open the level blueprint. I'm going to go ahead and open the level blueprint. Notice that the level does not have any components. That's the big difference between the level blueprint and object blueprints. Mr. Figueroa, so which do we use for which? It's in the name. If the level is doing anything special, like loading any very specific things or has any specific things that are not character-based, the level blueprint is what you want to use because it modifies the level. Character or object blueprints are specifically for actors that are going to be behaving in the level, and yes, they can speak to each other. We'll talk about casting when we get there. Casting is just blueprint communication, or in the commonality of code, treat as, if you've ever heard that term before.
Yeah.
Treat as or do behaviors as.
Yeah.
So what I'm going to do, just kind of keep it simple. On event begin play, I'm just going to print string. And I'm just going to print in text if I really want to. We want to get really fancy about this. No, we don't want to get too fancy about this. We don't have to do it that way. You can just type it in right there. What this is right here is an initiator. This is an event. Any red box is going to be an event. This one goes without saying. On event begin play, we're going to launch a print string. I'm going to go ahead and compile, save, and eyeballs up at the top left. There you go. That is incredibly basic. That's a lot more basic than, I guess, that's the most basic form of Hello World. Now, what we can also do, right now we are trapped in the game world. We are actually in play mode. So what I'm going to do is I'm going to say hello world. I'm going to delay 3 seconds, and then I'm going to quit the game. Not quit the editor.
You can't play this game.
Hit play, 1 1000, 2 1000, 3 1000. There we go. It kicked us out of the game world. Did everybody see kind of how now we're back in the editor world? Here, watch it again. 1 1000, 2 1000, 3 1000. Boom. There we go. Blueprint logic can typically be used to kind of create more or less anything that you need behavior-wise as far as blueprints are concerned. Go ahead.
Okay, so can you create variables in blueprints?
Yes.
Absolutely you can.
Stay-
Yes.
That will change over time, and every time that, like, let's say every time you go into the game mode, it like changes the variable up by 1. Is that
That's
possible?
just indexing, yeah. That's
Okay.
That's very straightforward.
Cool.
Let me do another type of hello world here. I'm going to break the behavior of our level hello world by abandoning this print string, alt and left click to break our command here. And what that's going to do is it's going to make it so it doesn't quit. We're in the game forever, and in fact the hello world is broken now. Let me create an asset that has a similar behavior to that. I'm going to create a new BP class, and this is going to be an actor, and this is going to be BP hello world. I'm just going to go ahead and do the same thing fundamentally. So what I'm going to do here is, let's see what I want to do here. Don't want to use my default scene root. No. Let's go ahead and do it this way. Do I want to use a sprite component? Let's do it this way. Use a billboard component. We'll do that. For those of you wondering where that dinosaur head came from, that's actually one of the scars from Unreal Tournament. It's been there forever. It's older than I am. So what I'm going to do is I'm going to create a placeholder sprite for that, and then what I'm going to do is underneath that, as a child, I'm going to add a text render component. Now I'm going to move the text render component so that we can see it, and I'm going to centerify it. I'm going to rotate it as well so that it's facing up, because right now it's facing forward because that's what it does. I know I've got one more minute, but that's okay. And I'm going to go ahead and call this Hello World so that I actually physically have it. Oh, my recording. Okay, we're doing okay. Now, what I'm going to do is, on the initial event, what I'm going to do is on event begin play, we'll discuss these in the future. I am going to go ahead and, oh, look at those variables that are set from the component stack. As you can see, it's automatically creating variables for us. So what I want to do is I want to grab my hello world text. And we'll talk about this when we get more in depth. And what I'm going to do is I'm going to set text on event begin play. And that text value is going to be make literal hello world. Compile and save that. So what this is physically going to do is once this actually runs, watch what happens here. I'm going to drag out my BP hello world into the world here. If it lets me, come on. There we go. Now it looks like it's going to print the word text, but once I hit play, it's going to modify itself as soon as it fires off into the hello world. I know I shouldn't have made it white, but I apologize. This is the same kind of idea of creating your first object that has running behavior. What's physically happening here is, by default, this object has some placeholder text. And in fact, if I really don't want that placeholder text, I can just go in here and eliminate the placeholder text. I'm going to save that. Now, when the game runs, as soon as we hit play, the setText function is going to run. SetText is a behavior that's already inherent in the engine. A lot of these nodes are already baked in to create some basic behavior. You do not have to create your own code in order for it to work. These are C++ functions that take in these behaviors and then do what it says on the screen. In this case, what I'm doing with my text component, in fact, I don't even want to call it that. Let's call it my text component to use. This text component contains all of the information of the text that we want to use. We saw that I erased that. What I'm doing here is I'm saying, hey, as soon as we press play, set the literal text to whatever this component is using, and then make sure that that's set for us. So notice how the text disappeared, but as soon as I hit play, we see that it actually renders out our hello world. So now we understand at the very least printing hello world on screen and creating an asset that is going to have that behavior for us. It gets a lot more complex from here. I'm not going to assign any homework for us because unfortunately we lost a little bit of time at the beginning. We'll do some more blueprint stuff next week. Then I'll assign the assignment. The blueprint is going to be creating kind of like your first collection game. It's going to be very basic, but it will work. We'll talk about creating a character controller. We'll talk about picking things up. We'll talk about creating overlap behaviors, so on and so forth. We'll add some music maybe, if I have any music. And that should be the intro to our blueprint stuff for now. We've got some more blueprint stuff to come in the future. So, do I have any questions about what I've covered for today? Go ahead.
For next week, the studies are one project.
No, we're moving on from that to use to create some new blueprint stuff. So we don't have to continue using your project. Yes.
What's the assignment for next week? Like, what are you looking for exactly?
For the
For
blueprint
the one
stuff?
that's due tonight. For the lights and stuff.
Oh, is it not explained in the actual assignment, or?
I was just kind of confused, like, by what is the, I forgot now. Never mind.
Are you sure?
Yeah.
Essentially, what I'm looking for is create some materials, apply it to the scene. Whether or not you use your original scene is okay. I provided a secondary scene for those people who are still falling behind and struggling to kind of keep up because of hardware or whatever. Provide 2 lighting scenarios, one in Lumen and one in Lightmaps, and create a recording demonstrating both your levels and how you created. The idea is that some understanding of materials should be achieved, some understanding of the lighting should be achieved, and the proof of that is going to be in the recording. Go ahead.
You said how you made them? Because I just had the walk through.
I would like to see how it's made.
Okay.
Which means if you have any nodes or tiles or anything that's happening in the actual recording, I would love to see how it was built.
Okay.
How do you bake the lighting again?
Build lighting.
You can build all levels or control shift semicolon, which is build lighting only. Now remember, in order for that to work, you have to have Lumen disabled. And then you have to use the post-process volume or the project settings to disable Lumen, because if you bake with Lumen on, it's just going to ignore the bake. A good way to check to see if you have any bake is if you go into your world settings, and if you go into light mass, and if you have light maps, and you check the light map to see if it looks like your environment. Sometimes you can have light maps in Lumen, they're ignored, but if Lumen is on, light maps will not bake an environment light maps, or light maps, so. Any other questions, folks? If there's any questions, remember that assignment is due tonight. Technically, feel free to send me an email. I've got a couple of things we have to cover a little bit. I've got some time that we can go ahead and take a look at it. But other than that, I apologize for not assigning the blueprint stuff tonight. I wish I would have gotten a little bit further in it. Don't worry. Before I let everyone go, who has controllers? Who has like an Xbox controller? If you want to bring it next week so that we can test out the Xbox compatibility, basically controller button mapping, you can. It's not going to be required. We'll use KBM by default, but I need to show people how to map the controller just in general so that people understand how to kind of do one or the other. It's basically just input mapping and input mapping context. So we'll talk about that when we get there. If you want to bring it, I brought mine, but we didn't use it today. It'll help you understand how to kind of create your own controllers as well, so we can go from there. All right? All right, I apologize, folks. I'll make sure that this gets fixed, at least so it doesn't happen again. I'm pretty annoyed about it. Take care of each other. Drive safe. More blueprint stuff next week.
Hey, is there a way to apply like multiple materials to gray box? So like I made my thing with a tile map, I think it was called. That's like my entire structure was built in.
Right.
How can I apply different materials to it instead of just one material?
The simplicity of creating something like that basically locks you into only using one material. The way that you would want to create an object is one, I would export that object into Maya, and then I would apply different blends to different sections that imports that re-import that object, and it will have several elements to it. In fact, I can show you that right now, I believe. Let me see if I still have that asset. I'm not crazy. Do I not have that asset? Color, where's my... No, I do not have that. Hold on. Let me go ahead and grab that from... Oh, I can't type. Where'd it go? Are you really gonna do me like that? Dumb. There it is. Wrong desktop. This way. I don't have to do any conversions because it's going to work. Go away, world settings. Sorry. Each of these were just different blends that were applied in. See, actually, I didn't even apply a blend. They're just the Maya standard surface. When you apply a standard surface in Maya and then re-import it into Unreal, it reads those as separate elements, as you can see. So we can add anything that we want in these individual areas. You can see how it's kind of broken up. I apologize, the light's on the weirdest side. There we go. So you get the idea. We can separate these out manually, but you'll have to export it into a modeling program of your choice. It's a little bit easier that way than to try to force it to use the modeling toolkit in here to try to break it up a little bit.
It's easier to use something else.
It's easier to just use a program that you're more familiar with. Blender is the same way. If Blender applies a material, that material can be brought into the elements here. If you want to unwrap it, that's the other technique. Unwrapping is a whole new can of worms, which but this is probably the easiest way to kind of add your own materials, essentially separating the asset out into components. This is not super efficient. Most of the time in games we'll want to at the most have maybe 2 or 3 elements. Like a character's face is going to be its own element on its own map, and then its body, and then its assets. That's how characters are typically made. But in this particular case, for simplicity's sake, applying a multiple standard surfaces to an object and then re-importing it would work the best. So if you made yours in Unreal, select it, make sure it's at 0, 0, 0, otherwise it will fly into a variety of different places. Export selected, and it will export an FBX. And then from there you can just do whatever you want with it. That's the nice thing about it.
Thank you.
Oh, I'm still recording.